So our next speaker today is Mike Drob from Cloudera. He's a software engineer in Cloudera, and I'll turn it over to Mike.
Thank you, Eli. All right, folks, I want to start this off with a little moment of zen. A lot of us traveled to get here. Some of us had less than pleasant experiences, so just close your eyes, deep breath. Okay. Everybody good? We're good? We're happy? Awesome. I'll introduce myself later. We'll get to that. I want to know a little bit more about you guys, though, first. Who has used Accumulo? Wow, that is way more hands admitting to it than I expected. I thought you'd be like, not tell me anything. All right, who has used Accumulo in production? Oh, that's like a third of you. All right. And who has found it that it's like fast enough and works for everything that you want to do in production? Yeah, it's never fast enough. Nothing is ever fast enough. So now that I know about you, a little about me, I am a Cloudera software engineer. I am an Apache Accumulo committer, PMC member. I've been doing that for a while, a year, over a year, I don't know. Everything tends to blend together. I'm a perpetual tinkerer. I like Legos. If you read my bio on the website, I categorically deny everything. I no longer live in Baltimore. Recently moved to Houston, Texas. Yeehaw. I might start saying y'all a lot. It's grown on me. So why are we all here? We're talking about, how fast is fast? What does it mean to benchmark? What does it mean to measure performance? So we'll talk a little bit about methodology, what we're measuring, how we're measuring it, what we're doing. Then we'll compare Accumulo over time, that's across versions. We'll compare Accumulo to another product, the elephant in the room, if you will. And we'll see what kind of conclusions we can draw and what kind of lessons we can learn. Measuring performance is hard because there's so many things to measure. You can measure task latency. How long does it take something start to finish? You pull out a stopwatch and you say, all right, ready, go. 1 Mississippi, 2 Mississippi, 3 Mississippi. You can measure throughput, that's bytes per second, operations per second. You can measure individual operational latency. Lots and lots of different things you can measure. I'm going to make it easy on you guys. I'm only going to talk about throughput in bytes per second in my charts. I have a lot more charts. I was told to take them out. If you want to talk about it more later, I'm going to be floating around probably at the booth, or you just find me later. I have way more charts if that's your thing. Then that's how we're measuring. There's also the question of what you're measuring. You can measure read performance. You can measure write performance. You can measure sequential workloads, random workloads. You can measure mixed, all of the above. I'm going to focus on reads, writes, and a little bit of 50% mixed read and write workloads. Those might not be representative of your workload, but hopefully there's something that you can extrapolate from, and you'll at least have a basis for comparison. What did we use? We used something called the Yahoo Cloud Serving Benchmark, YCSB. Huge thanks to a fellow by the name of Brian Cooper out of Yahoo. He's the main maintainer of this. Huge thanks to some folks at Carnegie Mellon that developed the initial Accumulo implementation, the connectors. What does YCSB provide? It's broken up into two parts. There's things we call workloads, which determine, are you doing reads? Are you doing writes? They determine how big of data you're writing, all of this stuff that's bulleted out, highly configurable, how many rows, how many columns, the size of each value, and you can configure the mechanics. How many threads are you using? How many clients are you using? Everything under the sun. There's the whole list of like 50 different knobs you can tweak. Then there's the connectors. The connectors are really what I think are the value of YCSB, because you can take the same workload and you can throw it against a JDBC connector. You can throw it against the MongoDB connector. You can throw it against HBase, Cassandra, Voldemort. They have 15 or so of these across the board. Anything that can claim to be a database or a key value store, you can probably figure out how to make a connector for it. So let's talk about Accumulo across versions. Some basic preliminary stuff out of the way. I used Accumulo 144 CDH4, our release. This is basically the same thing as upstream Apache Accumulo 145, the latest in the 1.4 line. Then we used our beta version of the 1.6 CDH4 release. This is pretty similar to the upstream 1.6, except we added a few of the unreleased 1.6.1 performance patches into it. There were known issues. We thought, it's not really going to be a fair comparison if we're comparing against something that has known performance degradation, so we'll look at that. YCSB, they actually haven't released something in 3 years, but their code's all on GitHub, which is awesome. So it's YCSB version 14 plus 50 or so patches. Really, it's just the tip of the master repository. This particular set was run on an 80-node cluster. Nice little monster truck right there. I used 10 clients. Everything was split across 5 racks. These workloads were, I think I have it here. Yes, 200 gigabytes being written. So we had some other workloads that were larger. We found that when we were writing 2 terabytes and 20 terabytes, the throughput was pretty much the same. So we lowered it down to 200 gigabytes in the interest of getting more runs in so that we can see, are there outliers? Are there things that are, actually consistent across runs? 2,000 columns, pre-split the table into 80 tablets. And the thing that we varied was the number of rows and the value size, keeping the data consistent at 200 gigabytes. It's going to make a lot more sense when I show you the graphs, I promise. And we did a lot more tests, but I couldn't figure out how to make them look pretty on the graphs, and those are the ones I took out, so ask me about it later. This is the read workload. I'm just going to dive right into it. This is probably what you all want to see. I think the numbers speak for themselves, but in case you can't read it, this blue line with the diamonds is Accumulo 1.4, the old version. This line that's higher is Accumulo 1.6, the new version. So we're happy. Higher on all of these charts, higher is better. We're talking about throughput, and that's the y-axis is megabytes per second. You probably can't see the numbers, but up top, the peak is just under 1,200, so a little over a gigabyte per second when we were doing our tests. You see this nice curve, and you see things, the throughput dropping off as you add more rows. There's more overhead when you're doing more rows, even though it's the same amount of data. We kind of expect this. And you see it's a similar curve, but higher for the reads. This flat line up there, we expect that that's client saturation. So the servers were doing just great, but the client, what we were using to write, was not able to keep up. And that's why we didn't see any difference. So that's the simplest graph and the most straightforward one. We can hop into, this is a mixed workload, where we did 50% reads, 50% writes. They were interspersed. YCSB has the ability to do that, just random, flip a coin, read, write, read, write. And we see the same kind of thing. High performance when we have a lower number of rows kind of trailing down. Remember, this is all still the same data size. And we have this weird peak at 1,000 rows on Accumulo 1.6, the newer version. That's weird. That's a little weird. But we ran this 10, 15 times at 200 gigabytes each, and that was pretty consistent. So we started wondering, what's going on there? It's going to be a little more clear in this slide. This is 100% writes. Accumulo 1.4 actually didn't, it was pretty stable across all the writes, regardless of the number of rows. We thought, okay, sure, you're writing the same amount of data. That we'll stipulate, that makes sense. And Accumulo 1.6, it has this peak again. It's weird. What's going on there? What's going on there? So what's happening? Write speed improved. That's great. We got better as the software improved. Read speed looks like it was about the same, maybe a little bit of improvement. And something weird's happening at 1,000 rows. It's faster, that's good, we like it, but it's weird. So here's that write graph again. What's happening at 1,000 rows? Actually, nothing. The problem's at 100 rows. Really, the graph, we should have this nice curve. Instead of, this isn't a peak, this is a valley. So what's happening there? We started looking at it, and for a long time we couldn't figure it out. We're still not 100% certain, but when you have 100 rows, each row is pretty big. That means the latency on each row is taking longer. That means there's a lot of committers in this audience, so I have to be very careful because you're all going to call me out on it if I'm wrong. But when you have larger rows, those take longer to write. Those cause blocking writes, or those cause more pressure on the T servers, which means the clients can't do as many operations per second, which means your parallelism isn't as good, which means your throughput goes down. I think. We haven't confirmed this. I really, really want to confirm this, but we're still working on it. So we've seen that Accumulo got better across versions, and I don't think it's a secret that we're not the #1 big table implementation, at least in terms of popularity. We're #2, maybe, probably #2. And that's okay. That's nothing to be ashamed of. But let's look at what's actually happening. I used the same YCSB version. I didn't have the 80 node cluster anymore. They took that away because somebody else needed it. But I had a smaller cluster, and I made do with that. 5 workers, pre-split, 5 tablets. Have the versions up there. And what happened there? I was using a single client here with 5 threads, and I had 2 things I wanted to try. we had a small 15 gigabyte workload. That would mostly fit in memory. And we wanted to see how that works. Then we wanted to force some disk activity. So we doubled that and went up to 30 gigabytes. This time we kept the number of rows constant and changed the number of columns, and still adjusting the value so we have a constant data size. And as we saw in the previous workload, the previous charts, the mixed workload was, it was just a mix. We didn't really get any new information out of it, so we weren't going to spend as much time on it. I have the write and the read workloads here, though. This one's kind of depressing, guys. I'm going to be honest. The red line's HBase. I'm just going to come out and say it. So here, this was 500 rows, and Accumulo is like right here, pulling a nice 100 megabytes per second. Oh, this is reading, yeah. We're reading a nice 100 megabytes per second, and HBase is like reading 500 megabytes per second. And their performance kind of goes down as you increase the number of columns, where we're about the same here when you have 1 million columns per row. But I don't know how many people actually have 1 million columns per row. So down here, HBase is kind of kicking our pants off. Not good, guys. Reading 30 gigabytes. These are on the same y-axis. This is Accumulo 1.6. Yes. 30 gigabytes. Accumulo actually got faster, reading more data, higher throughput. Not by much, but a little bit. And HBase got slower. So there's hope there. I'll come back to this. Maybe we should look at the write performance. Because everybody, for a while it's been said, HBase is faster at reading. We know this. Writing, 15 gigabytes. Accumulo is remarkably consistent across the number of columns. I was actually very impressed with that. However, HBase is still faster on the low number of columns, and then we overtake them on this high end. Okay, this is in-memory performance. Let's get some disk activity mixed in. These have the same y-axis. All right, that's better. So HBase starts coming down, and unfortunately, I don't have a 100 gigabyte comparison here because I just didn't have time to run all that. But it gets closer. The gap keeps closing as the data size increases. I never saw that we were able to beat them, except at this crazy high number of columns. But Accumulo does a great job of being very, very consistent. So I'm going to go back here. Reading 30 gigabytes. I found out later that HBase was actually cheating in this comparison after I made these slides and after I sent them in. They have an asynchronous client. And when you can do things asynchronously, you can read a lot more data faster. What's the takeaway from here? Don't believe benchmarks. Don't believe my benchmarks. Yeah, async HBase. Yeah. So that's actually async HBase, not regular HBase. So what did we learn from this on Accumulo's side? We tried a lot of different things. We ran a lot of different tests. And the number of rows and columns that you're writing actually matters quite a lot. Data layout, probably the biggest thing you can do to change your read and write performance. It's the same volume of data, but how you access it really, really matters. And people intuitively grasp this, and they're like, oh yeah, it matters. I get that. And then they go off and they completely ignore it and don't do anything. It really matters.
Did you have the write-ahead log turned on?
Yeah, these were all using write-ahead logs. We looked at setting the replication on the write-ahead logs, changing that between 3 and 2 and 5 just doesn't matter. And we found that not really. There's about a 10% difference between using 3 replicas and 2 replicas of the write-ahead log. But, I mean, that's not huge when you're considering 33% more data. Batch writer threads, the number of threads and the buffer size that you're using also really matter. The defaults are good for some values. All the charts that I had, they use the same values for the number of threads and the buffer size. If you use a large buffer for small values, then you can amortize the writes. If you use a small buffer for large values, then you get way better memory performance and we see a lot less garbage collection pressure. Accumulo 2766 is a JIRA that we didn't have time to include in the testing. It might help. I'm seeing John say it doesn't.
It helps with metadata write performance. So speed of ingest.
Okay, so it speeds up ingest, maybe. Yeah.
That's not client side. Not client side, not
Right. So tweaking the buffer size matters. When I was doing Accumulo for, we were trying to do ingest, at first we didn't even think about these. We were like, oh, defaults, whatever, that's fine. Yeah, no. You actually spend some time and play with these. What can you do server side? Apply a lot of table splits, they matter, they help. Actually use all of your tablet servers. Increase your split threshold. The default is 1 gigabyte. That may or may not be what you want. There's a lot of different knobs on Accumulo. We try to set sensible defaults, but your workloads are not my workloads. I can't help you with that. We were running with data node syncs. We found that disabling those sometimes matters. I couldn't figure out a pattern, but one thing that was super useful, if you're running with data node sync on close, this is a Hadoop property, also set sync behind writes. It lets you sync as you're writing, and it kind of spreads out your disk activity. There's a lot of people who helped. There's a huge community here. There's a lot of interest, obviously. I want to thank all of you for coming. Thank all of the developers that contributed. Check out our booth. Come talk to me. There's my contact info. And are there any questions? I think I still have a couple minutes. Yeah. This one?
Yeah.
Okay, I'll just leave it up here in case people wanted to write down those properties. Thought I saw a question over, yeah. So the question is, how do the reads happen? Is the concern about the read of the first block or the read of the subsequent blocks. I'm not sure. We didn't spend time to profile that. And that is something that needs to be considered. I wish I had an answer for you. That is something I'm going to look at, though. These graphs were, the question was, are these before or after the tweaks? They were after some of the tweaks. And the reason is these tweaks have different effects on different data sizes. And when we tweak, if we tweak the log threshold, for example, then that improves small data sizes, but can sometimes have a negative impact on the large data sizes. So I think it's those three properties in particular were kept at their default values for the graphs shown. The batch writer settings were also at their defaults. We found changes, we found improvements for some data sizes, for some permutations, but we weren't comfortable graphing them because it felt like we were trying to cheat the benchmark too much, which some people were suggesting, make Accumulo look good, but the data is what it is. Does that make sense? Okay. Yep. What would it take to make Accumulo catch up with HBase? More time to play with it, I think. There's so many knobs. I listed 3, 4, 5, like a handful here. I listed a handful of knobs. And I think that through configuration settings alone, we can probably get most of the way there. I do believe that. Because we saw some really promising results. But they weren't consistent, and that was the problem.
How much did you tweak in HBase to be able to?
Nothing. I used default HBase settings using, yeah, that was the,
Versus with Accumulo, you're tweaking all these things and
yeah,
bring it up.
yeah. So like I said, the graphs were mostly untweaked because we couldn't get consistent results. As a community, we can improve a lot with understanding what our defaults mean better. Some of those values were picked, set as the default 3 years ago because that made sense at the time, and nobody's ever thought to go back and revisit them. That's something that the community can really help out with. That's something that the users can help out with and say, oh, I tried this. These are settings that helped. Maybe they should be the new defaults. Yep. So there's a difference between hflush and hsync semantics, different things that Accumulo and HBase do. These are default settings, and while tweakable, there's a lot of things we can point to and say, this is part of the reason why it's faster. And I agree that the hflush and hsync is an important distinction. However, I think the onus is on the Accumulo community and the Accumulo developers for us to figure out maybe these defaults don't make sense anymore. I think that's part of that larger conversation. So we see that there's room for improvement in both. Where do we want to start? And personally, I think that working with the dirty little secret here is if you don't care about latency, then you shouldn't be doing batch writing. You should just map reduce, create all your data, and then bulk load it. So I think the write path already has an alternative that you can use if you're willing to make some trade-offs there. The read path, you can map reduce over it. There's other tricks you can set up. But I think the read path is really important. And we can see that early in our development, we focused on the write path, and HBase spent more time focusing on the read path. I think these graphs can tell that story. We need to look at the read path for people that want those millisecond or sub-second queries. Can we get those done? Yeah, sometimes, if you tweak all the right knobs. What are all those right knobs to tweak? We need help. All right, thank you.